Okay, so today we'll start from question number 6. Just have a look on the question number 6 once. Question number 6 says that uh, find the Cartesian equations of the line passing through the point 2, 4, minus 2, 4, minus 5 and parallel to given line x plus 3 by 3, y minus 4 by 5 and z minus 8 by 6. We have to find the Cartesian equation here. Okay, so look, given equation is, given line is, question number 6, given line is, given line is x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6. Okay, now tell me one thing, what is the direction ratio of this line? Can you tell me what is the direction ratio of this line? X plus 3 by 3, y minus 4 by 5 and z minus 8 by 6. So the question is, what is the direction ratio of this line? Come on, tell me, what is the direction ratio of this line? Quick. Direction ratio is given here 3, 5, 6. Very good. 3, 5, 6. This will give you the direction ratio. Okay, so we have to find the Cartesian equation of the line. Suppose this is our equation number 1. Okay, so we have to find a Cartesian equation of line which is parallel to this line and passing through a point minus 2 comma 4 comma minus 5, minus 2 comma 4 comma minus 5. Through this point, if I draw a line parallel to the given equation, so we have to find out what is the equation of this line. Now look, we know that direction ratio of this line is 3 comma 5 comma 6, and we know that if two lines are parallel to each other, so their direction ratios are same. Means as this equation as our required equation are parallel to each other, so direction ratio of this line will also be 3, 5 comma 6, isn't it? Now we know the direction ratio of this line and one point on this line, so we can easily calculate the equation of the line. Okay, so let's find the direction ratio of the line. So direction ratio of equation number 1 is 3, 5, 6. Okay, and as the required line is parallel to equation number 1, that means direction ratio of the required line, direction ratio of the required line will be 3, 5, 6. Therefore the equation of the line is, equation of the line passing through the point minus 2 4 minus 5, whose direction ratio are 3, 5, 6 is, we know the formula, x minus x1, that is x plus 2 by 3, is equal to y minus y1, that is 4, by b is equal to z minus or minus 5, that is 5, by 6. So this is the required line which is parallel to this line and passing through a point minus 2 4 minus 5. This is the equation of the line, and hence solve. Okay, understood? Understood? Okay, now we'll solve question number, uh, 7. the Cartesian equation of a line is given, we have to write the vector form of the line. Cartesian equation is given, we have to find the vector form. Okay, let's see how we can solve the problem. Now see, look, the Cartesian equation of the line is given that x minus 5, this is question number 7, x minus 5 by 3 is equal to y plus 4 by 7 is equal to z minus 6 by 2. This is the Cartesian equation of the line. We have to find the vector equation of the line. Okay, now from this equation we can say that this line is passing through the point 5 comma minus 4 comma 6. Okay, and the direction ratio of the line is 3 comma 7 comma 2. So that means number 1 is passing through the point the points 5 comma minus 4 comma 6, and direction ratios are 3 comma 7 comma 2. So the line, a point on the line is known and the direction ratio is also known. Okay, so direction ratio vector will be direction ratio vector, that means B vector will be 3i cap plus 7j cap plus 2k cap. Okay, and any point on the line is 5 comma 4 comma 6. So that means if the vector equation of the line, so vector equation of the point means position vector of the point, and the line is passing through the point let the point is a vector, means whose position vector is a, is 5i minus 4j plus 6k. Now look, we have to find the vector equation of the line which is passing through the a vector and whose direction ratio or the line is parallel to b vector. So we know that the equation of the line, or the vector equation of the line is equal to a vector plus lambda b vector, a vector plus lambda b vector. Okay, now just put the value. The value of a is 5i minus 4j plus 6k hat plus lambda into this b vector, means 3i plus 7j plus 2k. So this is the vector equation of the line, of this line 1. Okay, so see, have you understood or not? I just put a r here. R is equal to, r vector is equal to this. Now tell me, have you understood or not? Yes, understood. Okay, now we'll skip one questions. Now next question will be question number 9. You just have a look on the question number 9. Question number 9. Question number 9 says that find the vector and the Cartesian equation of the line passing through 2 points is given. We have to find the vector equation of the line and the Cartesian equation of the line. Okay, so let's there's a one point whose coordinate is 3 comma minus 2 comma minus 5, and here is another point whose coordinate is 3 comma minus 2 comma 6. So we have to find the equation of the line joining these 2 points into vector form and into Cartesian form. Okay, vector form and Cartesian form also. So first we'll calculate the Cartesian equation of the line, and then we'll do the vector form of the line. Now look, we know that the Cartesian equation of line passing through 2 point x1 y1 z1 and x2 y2 z2 is x minus x1 by direction ratio of the line, y minus y1 by direction ratio, means b of the line, direction ratio, second direction ratio. Okay, so first find the direction ratio of the line. Okay, so this is our a point and this is our b point. So direction ratio of the line AB is, or ABR. Okay, so direction ratio will be 3 minus 3 x2 minus x1 comma y2 minus y1 minus 2 minus of minus 2 comma z2 minus z1 6 minus of minus 5. That means 0 comma 0 comma 11. So this is the direction ratio of the line which join these 2 points. Okay, so Cartesian equation of the line, Cartesian equation of the line passing through the point 3 comma minus 2 comma minus 5 and whose direction ratio are 0 comma 0 comma 11. 0 comma 0 comma 11 is x minus x1, that is 3 by corresponding direction ratio, is equal to y minus y1 by 0 is equal to z minus z1 divided by 11, which means x minus 3 by 0 is equal to y plus 2 by 0 is equal to z plus 5 by 11. This is the Cartesian equation of the line. This is the Cartesian equation of the line. Tell me, have you understood or not? Up to this it is clear? Up to this Cartesian equation of the line? Okay, now we'll calculate the vector equation of the line. Okay, so I'm rubbing this portion. Okay, now we'll find the vector equation of the line. Now look, as the line AB, look, as one point, let the A point is lie on the line AB. Okay, so we are considering the position factor of A as small a. Okay, so position factor of the point A is small a is equal to 3i minus 2j minus 5k. 3i minus 2j minus 5k. This is the position factor of the point A. Okay, position factor of the point A. Now we have to find the directions of PQ in vector form. Okay, so in vector form, the directions of PQ, the direction of the line PQ, direction of the line AB, if I said it by B, so B vector will be equal to 3 minus 3 I hat plus minus 2 minus minus plus 2 j hat plus 6 plus 5 k hat. So this is the direction ratio of the line. So that is 0i plus 0j plus 11k. Now we have to find the line equation of the line passing through the A vector and which is parallel to b vector. So the equation of the line will be r vector is equal to a vector plus lambda b vector. Now put the value just. A vector is equal to 3i cap minus 2j cap minus 5k cap plus lambda into b vector means 0i cap plus 0j cap plus 11k cap. So this is the vector equation of the line passing through these two given point. Okay, and hence it is completed. Now tell me, any problem from your side? Any problem from your side? Okay, now if you look at the question from 10, 11, 12 and 13, all questions are related to finding the angles between two lines, and you know that this portion has been deleted from your syllabus, so we will not solve this type of problem here. The angle between any two line, any two plane, and angle between a line and a plane, this topic has been removed, so we will not do it. Okay, so we are just neglecting the questions, just skipping the questions. Just come to question number 14. Okay, so question number 14 is find the shortest distance between the lines. Two line is given here. The first line is r is equal to I plus 2j plus k vector plus lambda into I minus j plus k vector. This is the first vector, and the second vector r is equal to 2i minus j minus k plus mu into 2i plus j plus 2k vector. This is our equation number 2. So we have to find the shortest distance of these two lines. Okay, now if I compare equation number 1 and equation number 2 with r equal to a1 vector plus lambda b1 vector and r is equal to a2 vector plus lambda b2 vector, then we have a1 is equal to this vector I plus 2j plus k. b1 vector will be equal to this one I vector minus j vector plus k vector. Similarly, a2 means this vector. a2 vector will be 2i vector minus j vector minus k vector, and b2 vector will be this one 2i plus j plus 2k. Okay, and look, we know a formula to finding the shortest distance between line, which is the form r equal to a1 plus lambda b1 and r equal to a2 plus lambda b2, and the formula is shortest distance is equal to mod of b1 cross b2 dot a2 minus a1 vector by mod of b1 cross b2 vector. This is the vector equation to find out the shortest distance between two lines. So from here we will calculate b1 cross b2 and a2 minus a1 first. Okay, so find b1 cross b2, b1 vector cross b2 vector means cross product of these two vectors. Find it out. So first I j k and the component 1 minus 1 1 2 1 and 2. Okay, write the component of I, j and k and make a different determinant of order 3 by 3. Now expand this. Okay, and tell me what will be the expression of b1 cross b2. Quickly tell me the expression of b1 cross b2. I'm giving you 1 minute. Tell me the expression of b1 cross b2. What is the value of b1 cross b2? Quickly tell me the value of b1 cross b2. Okay, so I'm expanding it. So I hat into, just cover this row, a column, and this row. So -2 -1, so -3. So that is -3i plus j into 2 -2, that is 0. So that is 0j plus 1 -2, that is 3k head factor. So b1 cross b2 is equal to -3i plus 0 -3k. Now find the mod of b1 cross b2. So that will be under root over of, that is -3 square plus 0 square plus 3 square, means 3 root 2, that is 3 root 2, root over of 18, that is equal to 3 root 2. So b1 cross b2 is known. b1 dot b2 is this. Now we have to calculate a2 minus a1. So here calculate a2 minus a1, a2 vector minus a1 vector. So this is your a2 vector and this is your a1 vector. So subtract this a1 from your a2. So 2 minus 1, that is I, minus 1 minus 2, that is minus 3j, and that is -1 -1, that is equal to minus 2k. Okay, so all the values are calculated. b1 cross b2, a2 minus a1, and mod of b2 minus b2 cross b1. Okay, now put it here. So therefore shortest distance is equal to, write this formula and then put the value. So b1 cross b2 is equal to this one, -3i plus 3k into a2 minus a1 means this one, I minus 3j minus 2k by mod of b2 minus b1, that is equal to 3 root 2, and modulus of this one. Okay, now find the dot product of these two vectors. So that will be -3 mod of -3 0, and this is equal to -6 by 3 root 2. So 9 by 3 root 2, 9 by 3 root 2, that means 3 by root 2, or 3 root 2 by 2 is the answer. 3 root 2 by 2 will be the answer, or you can say 3 by root 2. Okay, now this question is complete. This is the formula to finding the shortest distance between any two line. Now tell me, have you understood or not? Quickly tell me, have you understood or not? If you have any problem, you can tell me, because this is a very important question. Yes, okay. Now we'll find the shortest distance between any two Cartesian line. That is question number 15. Okay, so let's find out question number 15. Question number 15, two equation of line is given in Cartesian form, and we have to find the shortest distance of these two line. Okay, so let's write the equation first. So the equations are x plus 1 by 7 is equal to y plus 1 by -6 is equal to z plus 1 by 1. This is the first equation, and another equation is x minus 3 by 1 is equal to y minus 5 by minus 2 is equal to z minus 7 by 1. This is our second equation. So you have to find the shortest distance between the first equation and the second equation. Now look, one thing, we know the formula to finding the shortest distance between two lines given in Cartesian form, and the formula is shortest distance d equal to determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by under root of r of b1 c2 minus c1 b2 whole square plus a1 c2 minus c1 a2 whole square plus a1 b2 minus b1 a2 whole square. This is the formula to finding the shortest distance between any two lines. So first we have to calculate this determinant and this value. Okay, so first calculate the value of this determinant. Okay, now here look, what is x1 y1 z1 x2 y2 z2? x1 y1 z1 and x2 y2 z2 are the point on the first line and the second line. So here look, this equation contain the point minus 1 minus 1 minus 1, all are minus 1. Yes, so x1 y1 z1 will be this minus 1 comma minus 1 comma minus 1, and this equation contain a point 3 comma 5 comma 7. So this is your x1 y1 z1 and this is the x2 y2 z2. Okay, so find this value x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. Find the value of this, that is equal to, so 3 minus of minus 1, that is equal to 4, 5 minus of minus 1, that is equal to 6, 7 minus of minus 1, that is equal to 8. And this is your a1, this is your a2, and this is your b1, and this is your c1. a2 is 1, b2 is minus 2, and c2 is again 1. Okay, now expand this determinant and find out the value of this determinant. Okay, so let's expand it. So that is equal to 4 into minus 6 plus 2 minus 6 into 7 minus 1 plus 8 into, this is minus 14 and minus minus plus 6. Okay, now do the calculation. That is 4 into minus 4 minus 6 into 6, and this is 8 into this is minus what, 8 into minus 8, multiply it, so this is minus 16 minus 36 and this is minus 64. Now add them and tell me the value. Add them and tell me the value. Okay, now calculate this one, square of this b1 c2 minus c1 b2 whole square. Okay, the result of this, I think 116 minus 116. Okay, now find the value of this one, value of this. Okay, so that is equal to, okay, now calculate this. So b2, so that is minus 6 plus 2 whole square plus 1 minus 7 whole square plus this is 14, so minus 14 plus 6 whole square, that is equal to 4 4s are 16, 7 7s 6 6 are 36, and this is 8 8s are 64. So this result is also 116. This result is 100, but root over of 116. Okay, so therefore the shortest distance will be, the shortest distance between two lines d will be root over this minus 116 by root over of 116. So that is equal to under root over of 116 unit, root over of 116 unit. Okay, so this is the shortest distance of these two lines. Now tell me, have you any problem to finding the shortest distance between two lines? Have you any problem? Do this type of question very carefully. This is very important for your exam point of view. Okay. Now, so today we have completed this exercise, and if you look at the questions 16 and 17, they are same type of questions. So I am not doing that. Okay. So try to solve the question. If you face any problem, then tell me. In my next class I will definitely solve it. Okay, and in my next class we will going to start the plane. Clear? Okay, so today up to this much. Next we will start the chapter plane. Okay.